Okay, good evening everyone. So in this video, let me introduce myself. My name is Muhammad Dharil Pradipta. It is student number 124490074 in the year of 2024 from the RB class. So in this video, I would make a 30 minutes about PCB making, a simple PCB making using microcontroller, one LED OS2812, one resistor, and connector with two pin. Make one custom footprint from the beginning for LED OS2812B, the layout, and set the via the way of the component, I guess. The track, yes, the track between component. The upload to YouTube. So first I will go to the Kicad. Let's open up Kicad. Here I've made the file, just file, new project, and rename. Select wherever you want to be. I select on the task, create, then I go to schematic editor. In order to create the footprint, I have to know what it looks like, what is the required from the datasheet. So let's press A for the symbol. Let's select OS2812B, isn't it? If I'm not mistaken, yes, the B1, the B version. Drop it here in order to see the exact datasheet that is a requirement. So I press the component, I click D for the datasheet, and it will redirect me to the right file. So here we have the current datasheet from the words M.Si. It says OS2812B, intelligent control ID, integrated light source. So here are some features and benefits. And here's the application. It's RGB, of course. Here's the general description. We can skip this. So here is what we are looking for. This is the exact design from the OS2812B. So here's the pinout, the function. Here should be the VDD, stands for the power supply LED. For number 2 is the DOut, stands for control data signal output. Here we have the VSS, stands for the ground. And here we have the DIN, to control data signal output, the same as DOut. The difference is that from the in, the signal will come in, and the out, the signal will goes out, redirecting into another component. So here's the maximum requirement. It says that it needs an amount of 3.5 until 5 and 3 voltage for the VDD, because it is the power supply LED. So it will supply the voltage from the power from the other components to inside this way as to it to be LED. And there is input voltage V1 for the 0.5, the operation junction temperature, storage, etc, etc. So here's the parameter. You can just read it through. So here's the required model, etc, etc, etc. So here's the design. If it were applied to our Kicad. So let us make the custom footprint. I will try to make the exact required shape and amount. So it should be PCB solder pad, the LED solder pad. So there are two kind of pad. Well, I will make it simple so we can understand it how it works. The orientation should be like this. It should be 5 by 5 with the what's this called? 9 millimeter width, and for the inside it should be 4.2. Here's 3.4. Should be 1.5. So you can just go to the footprint editor. Just click OK. Now I should go to the footprint editor. No, symbol editor. So let's create the new library by clicking File, New Library, select Global. So it will act for all the project. If it were applied to this project, just select the project. For this video, I will select for this project only. So let's press OK. Then we'll input this into the same file as the test tree. It should be fine. Let's rename custom OS2812B. Should be capital OS2812B. RGB. Done. So here's our file. We could create preset. Create new symbol name. To B. The U is the U. Okay, here we go. Code drop-ins. And so the datasheet says it should be, let me write it first. VDD, the input, the output, VSS, or let's say ground. Okay. Try to make the exact same shape. So let's just make the pin. It's for the input. Let's say VDD. Okay, let's put it. I can rotate it here, I guess. 1, 2, 3. Yep. Select another with the name din for signal, because it says so. Let's use it for bidirectional. Number 2. I should rename it. Use E for properties. Select number 1. Let it be. Now it's the number 3. It's for the out. Let's use it bidirectional, so it code transfer data, if I'm not mistaken. So pin number 4 with the pin name ground. So I won't confuse with another VDD and VSS, so it will make it easier. Let's say ground. It should be for output, for ground. Here we go. Well then, save. Could go through here to select the required. It should be. Can forget how it should be. So let's rotate it first. Should be like this. I try to drag so it won't have a distance to read the output. I think it's safe. So we draw the rectangle or perfect square, resize. So here we go. Select E. Wait. What else should I need? Let's see. I think it's good enough. You can go back to footprint editor. File, new library for this project. I should rename waste 2812b dot pretty because it is the required name for the format. Save. Okay, we can select the new footprint. Go to the file. I think should be custom. Yes, no. Ah, I have it. So now let's make the exact shape. Oh wait, I forgot. I should be making it looks like this, so it won't bothering me. I have to redesign the level again. I made a mistake. So let's put directly like this one. Okay. My bad. BSS, let's just say ground here. What does it say? Ground is number 3. Should rename it E4. Okay. Let's make it slightly bigger so it will be able to read. So you can see it clearly. If your pin is not going well as your plan, you can just select and hold control so it will hover around freely. Press it here. Another click and control to make it hover around. It should be at the same line. Like that. So just press it and it's the control. Well, I guess it should be fine. And we can go back from here. Click save. It's fine here. Alright, okay. Now we can make the footprint. So I will check the datasheet. It looks like should be look like this. So I'll just take a screenshot and paste it here so I can work normally. Let's resize it. Wait a minute. Should be not too much. I guess it's fine. We can start by drawing the rectangle. At this one, I think it's too big. No? Yes. Should be like this. And you can size whatever you like. Draw another perfect rectangle inside it. 1, 2, 3 should be enough. That should be buff. Yes. Can I edit? Yes. Yes. 2812B. Okay. Reference in the middle. Yes. Yes. Drag it a bit under, so it should be the same. Or just like this. Okay. 1, 2, 3. So let's add the. Let me think. Should be 1, 2. VDD. The in. The out. Ground. Okay, then let's go back. We can select add pad for number 1 here. Wait. Let's resize a bit so it can take more space. Select pad. I made a mistake. We should start over again with number 1. Sorry. Here we go. Number 1, number 2, 3, and 4. Correct? Yes, correct. Drag all along. I guess it should be on the this square. Edge cut, I guess, yeah. If I'm not mistaken. Edge cut. Click OK. It's the gray one. It's hard to determine whether it's a layer or not, or it's the user drawing. So I guess it's the user drawing. Okay, so let's click OK. We can simply select, click E for properties. It's the type SMD, OK. For the rectangle, OK. Just click OK. I forgot to draw a perfect circle here. Voila. There we go. We have our own custom-made WS281B. I suppose it is exactly the same. We can assign it later. I guess it's fine. Now we can go back to the schematic editor and show how it looks like. It's the current. So I would just simply by clicking this as a property, click E, you can switch the footprints by the custom. Where's no? Where's so it to be untitled. So it should be look like this. It's okay. It's okay. I think it's fine. So we can add the another component. SP32. Verum 1. Okay, drop it here. What else should I need? I should check. 1 LED VS, 1 resistor, and connector with 2 pin. Resistor, select R, and the what's that again? Pin connector. No, gone. 2 times 1, 0, 2. I forget the name. What's the connector? I think it's here. So if I am hesitant, I always check for the 3D print. No, for the 3D. It's usually like this. Print con gst underscore con connector. Not this one. 01 times 02. Forgot the pin. Is it so? Connector. Yes, it is. It's the one. You can select the footprint for all. This is for the SMD. It's the SMD 1206 1206 R 1206. So there are 2 types. It's the regular, it's the hand solder. So I'll be using the hand solder, so it will be easier. So here we go. We already have assigned the untitled footprint, and here's the ESP already assigned. Let's see what else should I need. One microcontroller, one LED, one resistor, one connector, 2 pin. One LED, one resistor, one connector, 2 pin, and a microcontroller. So you can just connect. If you are wondering which one should you use, you can just click here, pin helper, and global label. Select here also on this side. Select here. No. Select here. Pin helpers. Global label. So it's set for the ground. Okay. It's for the 3 volts. So just make a label. So I won't have to make the hard routine. So yeah, let's assign. Here says that the OS required number 2, so just click and duplicate. I'll stick it here. And what else? Resistor should be here. We won't be using pin number 2 since we just one. And for the ground, wait, where is it? Here it is, the ground. Just make the symbol. Let's see. And GND stands for the ground. Drag a bit to the side and let's assign it with the power. If it's too much or too many components, let's just press P for the power. 3 volt, 3 by 3, 3.3 volt current. Here we go. Let's connect this pin. on the top, we can use the IO0 to boot, and we'll duplicate the 3 volt here as well. Select 1, 2, drag to the other side so it won't bothering me from design. So here we go. So let's connect. Make a bit longer. We could use ground here also, and it's for booting the ESP. Let's make it a bit proper by dragging them all along. Here, no, is wrong. Or like that here. EN won't be needed, not for this function, so let's drag. So I can tell the difference whether those are connected or not. Again, give me a moment. Okay, let's connect the ground. Okay, and we have the schematics. What else should I need? Layout and tracks between component. So let's go ahead to PCB editor. We should make the edge for the layout. Here I will select edge cut, click the rectangle. Let's make the small one. 3 by 2, 2 by 3. 3 by 2 should be enough. And click here, update PCB, update, close. Click here. It's too small. Let's make it slightly bigger. Drag it here. It's too big. So here I will select the board setup, constraints, which will be 0.5 with the minimum track width 0.6, zero width via diameter should be 0.6, through hole 1.2, I guess. I can forget. Clearance 0.5, 0.6 via size. Via hole should be the twice of the via size 1.2. I think should be fine. Okay. So let's create by pressing the X. We can root here, go here. Okay, here we have the 3 by 3 voltage, so connect here also. Later connect here. I shall connect the ground here. Also here as well. Okay. So since the line won't interfere one with the other, I should select here X by clicking the V or the via. No, should precise. Delete, delete by clicking here via V. I have the blue simple line should be connect into here. By clicking V again, should be look like this. I guess it's too big or too much. So we code set again and through hole 0.6 I guess. Should be okay. So here we are, we have the simple system for the ASP32. So here's the current footprint that I've been made. It appears to be slightly bigger than the original footprint. So here's our assembly. So we should check the 3D design of how it looks like. So here we are. So I will place the put button here, and here's our SMD resistor. So here's our OS2812B. Here's the VIA. The thing is too big. I shall change the whole. So here it is. It goes way through here. I shall change it. Oh. Minimum via whole generator. I think it should be fine. Okay. 1.2, yes. My mistake. Here's the perfect size. So let's correct here as well by pressing E. 1.2. 0.6. VL is 0.6. So it should be right. We could select here by dragging here all along. Make sure it's not a 90 degree. Should be a bit longer so it won't interfere with the signal. Should be looks like this. Should be enough. Yes, here goes here. Or you could just move it. No. Could move so it won't go any further. Making it here. X. Connect. Here as well. Connect. Well, it says that the ground should be pair should be a bit bigger. So the track width is 0.8. Should be saver. It's only for the high voltage, so it won't cause any shortage or another reason. So let's check for the inspect. Here on the RC there are 53. What's the warning? At class clearance. Okay. Let's try to make it a bit bigger. Oh, I see the problem. So we can neglect all these red lines. It should be fine. Here is a bit trouble here. But we have no problem here from the current design. It's only for the design that are already had there. So it occurs also in my another PCB, so I think it should be fine since it's only the the silk screen when it's already there. Should be fine. And how about the warnings? It's the warning. Silk screen, it's fine, doesn't match in the RF module. Uh, well, for that you can check the library or datasheet, but I'm pretty sure the datasheet is already there, RF module. So I guess it's fine. So wait, ah, so here is my custom LED DSP. So then I can plug. Oh wait, show you the 3D. Here we go. So I can plug the power and it should run the PCB. And I guess it's fine. I forget the current footprint for the connector pin, so I guess it's the right one.